to JavaScript. Click JavaScript tutorial, and then from there we're gonna run a little program, and then we'll get the numbers that we can use on the OpenOffice spreadsheet to calculate the sun declination. And let's see. We're going to run a little program here. It's the for loop. If you look here on the left is the program. That shows you what this program does. So I just wrote a little program to kick out some numbers that we could use on the OpenOffice. So if you look at this program, you click edit, and click me. It's going to run the program, and it's going to print out 365 numbers, and each number is used for the day of the year. So there's 182 positive numbers, and 182.5 positive, and 182.5 negative numbers. If you add them up, it's 365 days. Each one represents a day of the year. We open Office, click Spreadsheet, right-click A, click Paste Special. Now HTML. Okay. And then all the numbers that we copied just recently, we pasted in column A. So we have 365 numbers in column A, and each number represents a day of the year. Alright? So now we have 365 numbers, and each number is highlight all these columns because the numbers are too small to read. So I'm just going to increase the size of the numbers to make them more legible. Scroll down to 365, days of the year. Click it, and then we're going to click 16, and that's going to give you the font size of the letters so you can read it. Alright? The next thing we're going to do is change the numbers in column A to be represented as a degree. So each day of the year will be a degree in a circle. There's 365 days in the year. There's 360 degrees in a circle. So each number in column A has to be multiplied by a factor of 360 divided by 365, and that will give you a number in B. And the number in B will be a degree. So each day has a degree. It's a degree of the circle. Alright, so we just put down A1 A365 times a factor of 360 divided by 365. So every number in column A is going to be multiplied by a factor of 360 divided by 365, and that will change the number in column B, and that will be a degree. So each day is a degree of a circle now. So now we have the days represented as a degree. So now, column C, what we want to do, if we want to plot the graph, we have to change degrees into radians because computers don't use degrees, they use radians. What a radian is, if you don't know, you can look it up in Wikipedia. It's just another way of saying degrees. So you're just going to change this. You go to function, click the array, go down to radians, click radians, and then go to next, and it says every number in B1 to B365 will be converted from a degree into a radian, and that's going to be put into column C. So column C is going to be every number in column B as a radian. We're going to convert column B into radians, and that's going to be in column C. Now what we're going to do, we're going to calculate the sine function. The declination of the sun, as I say, the sun, the highest point is 23.45, and it goes down to minus 23.45. we're going to calculate, we're going to graph the sun sign, or the declination of the sun. So we're going to go to sign. Make sure array is clicked. Go to sign. Sign function. So sine of the sine of whatever radian is in column C times times minus 23.45 will give you a declination of the sun, or the sun sine wave. So now we click that, we put in C1 to C365. That's sine, and we're going to say that times minus 23.45, because that's the maximum and minimum value, 23.45. And that's going to give you a sine wave graph. Now I'll click OK. Now in that column that's highlighted, that's the sine wave function. So that tells you the altitude of the sun at any particular day. The declination of the sun, actually. Now, see column B is highlighted? Column B is the y-axis of the graph. Okay, that's y-axis. So we're going to cut copy B and paste it next to the other column, because the column to the right of column G, the highlighted column is the y-axis of the graph. It's the x-axis of the graph. The column to the right is the y-axis. So what we're going to do is chart the sun declination, or the sun sine wave. So we put the two columns next to each other. We're going to highlight both columns, and then we click chart. See, it's easier to work with if the columns are next to each other. So that's why I cut column B and put it next to column that I just put it next to the other column. Let me see, I can't really read it. And see, now we have, this is X, Y. The right column, the left column is the x-axis, the right side, the right column is the y-axis. So now we have an XY. We're going to click chart, and we're going to graph it, XY. That's an XY graph. What we're going to do, we're going to say XY scatter. So each data set has its own icon. So we click yes. And this is the sine wave function. That's what we just plotted, is the sine wave. That's the sun sign, or the declination of the sun. Okay? Now we're going to resize the graph. Alright? Resize the graph. Pardon me. Now we're going to change the icon for each data set. I'm going to go to data series. I'm going to click that until it says data series. This is on the top left, it should say data series. If it does, great. Then you say line. Click line. Then on the right it says select. Then you can say gallery. So now you can change the icon for every data set, XY pair. So every XY pair will have its own icon. So we're going to make each little XY set has a little round. Well, it looks like the sun. So no, supposedly. So now we have the sun sign, or the declination of the sun, on the graph. The center of the graph represents March 21st, or the spring equinox. That's when the sun is at 0 latitude, 0 longitude. And that's 0. That's March 21st at about noon. So at about noon on March 21st, the sun is at 0 latitude, 0 longitude, in the center of the graph. If you go to the left, it increases. That means it goes from March, April, May, June is the high point. September is back to the low point, which is the equinox, for the autumnal equinox. If you go to the right side, it goes down to as far as December, which is the winter solstice. December 21st is the winter solstice. Then it goes back up to March 20th. So that's the graph of the sun declination. I'm going to show you a picture in Google because I already did this on the Google. I put this information on the Google Earth map. And I'll give you a picture of what I'm trying to tell you. Let me see. Oh, I'm just going to put in March 21st. We're going to put label each data set. Each XY coordinate has a day. So that the center of the graph is March 21st. I'm not going to type in every day because I don't have the time. I'll just put in March 21st. Just know that the center of the graph is March 21st. This is Google Earth map. If you look at Google Earth, you see like the teal lines. The line going up and down would be the y-axis. The line going left and right would be the x-axis. The center of the graph, like we just showed you, was March 21st. So that's when the sun is at 0 latitude, 0 longitude. The sun is at the equator on March 21st. If you go left, it's going to go to April, May, June. June will be the high point. If you go to the right, it's going to go down as far as December. And you can plot that on the Google Earth, and it shows you the declination of the sun. You can see that the sun goes to all the different constellations. And you can plot the sun, you can plot the constellations. Later on, we'll get into satellites. We'll plot the satellites. And so next time, we'll plot the declination of the sun on a Google Earth map. Right? All right, bye.